好 Okay, so all right, so let's just start now. There's still a few people who haven't arrived yet. Jason and Jaejeon will be arriving later, so you guys can expect them later. Then we would have 6 out of 7. Hopefully Davis also comes soon. Okay, so first off, I wanted to say that to clear up any confusion, like on what you're supposed to do for homework, what you're supposed to do for homework is that, okay. Okay, so what we're supposed to do for homework is that first off, you want to do all of the questions inside of the sheet. And then second off, you want to whatever. Okay. Yeah. We Okay, so just restarting my train of thought. You're supposed to do all of the questions. It's okay if you didn't do all of them this time because you guys probably didn't realize that you had to do all of the questions, but just remember for next time. And also the second thing you have to do is to prepare the question that you were assigned, or if you haven't figured out that question, then just prepare another question, preferably the questions that are unassigned. So that's basically the two things that you have to do for homework. And with that out of the way, let's just start with the first person. Victor, if you would please present question number 2.
Wait, so do I just like say it and you just because so just say how I did it, or
like there's a few different things that you could do. Like for example, you could first off list the possible math knowledge that is required for this problem and present them. And second, you can also present the strategy, like the general strategy you used going into this question, and then the process of solving the question itself, obviously, and any summary if you have a summary.
wait, okay, so I don't even know if I did this question correctly, but I guess like some important stuff for number 2 is like, so the variable k, the 2 points that are 3 and which is the x value and the y value 2k plus 1, and the x value 8 and the y value 4k minus 5. And I think parallel to the x-axis is like pretty important. So parallel means like 2 lines that are not touching each other. So what I did is that I know that the slope of the line parallel to the y-axis. So some math knowledge you need to do this problem, I guess, is to have like an understanding of slopes. So like rise over run and like the change in x, the change in y over the change in x. So what I did to solve the problem is that I know that the slope of a horizontal line is 0. And since the x value, the line parallel to the x value is horizontal, it has to be horizontal. The slope of the line is going to be 0. So now to solve the problem, so we know that slope is equal to rise over run, or the change in y values over the change in x values. So then all we need to do is just like plug in stuff and plug in the 2 values they gave us and do algebra. So it would be the change in y values. So it would be 4k minus 5 minus 2k plus 1 over, or divided the change in x values, which is 8 minus 3, and that would equal to 0 because the slope of the line is 0. So then we know that it's divided by 5. So 4k minus 5 minus 2k minus 1 divided by 5 equals 0. So we just get rid of the 5 by multiplying both sides by 5. So 0 times 5 is still 0. So now we have 4k minus 2 and -5 minus 1 will equal to 0. So then that would be 2k minus 6 would equal to 0. And if we do algebra, that would be 2k is equal to 6 and k would equal to 3. And to check if the answer is correct, you could just plug k back into the values. So 3, 2 times 3 plus 1, which is going to equal to 3, 7. And 8, yeah. And 8 minus 4k minus 5, which would equal to 8, 7. So I think it's parallel to the x value, to the x-axis. Yeah, I don't know if I did it right or not.
Yeah, that's correct. Okay, so what's the value of k then?
The value of k is 3.
Yeah, okay, yeah, exactly. No, there's nothing wrong with that. Yeah, so that is the correct answer. And you also talked about the strategy. I mean, not strategy. It was more like general knowledge. Is that you needed to know what was the slope of a line that was parallel to the x-axis. So for a line to be parallel to the, so actually, let me just screen share. Okay, so let's say we have a line that is parallel to the x-axis, a line that is parallel to the x-axis. Okay, so as Victor said, the slope would be equal to 0. So the slope is equal to 0. Now, can anybody tell me what an equation of such a line would look like? Like, for example, a linear equation, you would say that it can be generalized into fx or y is equal to ax plus b. So what would a line that is parallel to the x-axis be?
Delta y over delta x.
Delta y over delta x?
Like the change in y over
yeah,
change in
that's the slope. But I'm asking, like, what is the equation or the function for a line that is parallel line to the x-axis? Does anybody know? Okay, well, if we take, for example, the example inside of the question where we have a line that has the points 3, 7, and 8, 7. If we have these 2 points, we see that the x is changing, but the y isn't changing, which means that the y is going to be a constant. So the y is equal to a constant, and it's not related to the x. That's basically the equation of a line that is parallel to the x-axis. Or instead of y, we can write fx. Okay, now what about a line that is parallel to the y-axis? What would that line be? So first off, what would the slope be for a line that is parallel to the y-axis?
Not defined.
Yeah, undefined. That's right, undefined. Okay, but if we look at a line that is very close to parallel to the y-axis, which means that it's very flat, but it's not quite completely flat and completely parallel to that y-axis, then we see that it has a very large slope, which means that you could also say that the slope is pretty much infinite. Undefined infinite, because the difference between the x values is going to be 0 all the time. So that is a line that is parallel to the y-axis. Now, what is the equation for a line that is parallel to the y-axis? Well, if we have fx is equal to a constant for a line that is parallel to the x-axis, we have x is equal to a constant, because basically the fx is kind of like y, right? In our xy system, fx is just basically y. And so we have y is equal to c when the line is parallel to the x-axis, and x is equal to c when the line is parallel to the y-axis. Okay, so if x is equal to c, then what is fx equal to? We saw earlier here that fx is equal to a constant, which and x could be anything. So basically, fx would have anything in this case. Okay, and then now that we have, now we know that the line with the lines that are parallel to the x-axis and the y-axis are like, there's something else that I wanted to talk about functions, is that as you can see here, it's kind of weird how we have x equal to anything and y is equal to c, and vice versa right here. So what happens in this case if, like, we know that x is going to be equal to c and fx is equal to anything, right? So how can we write that down? We can write that down as fc to r for real numbers. And what this means is that, for example, if we take is it really a normal notation for a function? I'm not sure. But if we take a function, right, and then we have this type of notation, f(a) to b, it means that the we see that the a is the domain, which is usually x, b is the codomain, which is usually y. So let me explain. This notation f colon a arrow to b means that basically a is the all of the possible values, a is all of the values that work for any x, which means that, for example, if we say we have an equation, if we have a function f(r) to r, if we have a function f(r) to r, it means that all of the x values have to be real numbers. And what numbers are not real numbers? Imaginary numbers are not real numbers, which means that the x value can't be an imaginary number. It has to be in the set of real numbers. And then we have the b, which is the codomain. Codomain means that it has to be it's also basically just a domain, but for the y-axis. So if we have the real numbers here as well in the codomain, it means that we have a function that has all of the x's in the real numbers mapped to all the y's in the real numbers, meaning that y cannot be equal to, for example, an imaginary number. Okay, and then, for example, if we take our first example of a line that is parallel to the x-axis, we see that the x can be anything. So we have fr to c, because fx has to be equal to some constant c, which means that basically the y value is always c. It can't be any other values. But fr to r also works because c, a constant, is always a constant is usually a real value. So this also works, but this also works. And this just narrows the cases down a bit. And then if we look at our second line, a line that is parallel to the y-axis, we see that our x value has to be c. So we can just write down c, because c is in the set c. And we can map c to any r in the y-axis. And I see something in the chat. Okay, yeah, all right. Okay, so that's our domain and codomain. Now, if we take, for example, if we have a function, right, that takes the real values on the x-axis to the real values on the y-axis. And for example, this function is y is equal to x squared. We notice that y cannot be negative. Y cannot be negative. So the codomain does not mean all of the values that y can take on. There's another definition. So this definition is called the range. The range is basically all the y values that are obtainable. So the range is a subset inside of the codomain. Now, if we have, for example, if we have the function y is equal to x squared, then the domain and the codomain are the real numbers to the real numbers. But we have, but the range here is not just all of real numbers. The range is going to be any number that is greater than 0.
Wait, okay, like I'm sorry for like interrupting, but I don't know what's going on. Like I'm sort of lost. Like,
Oh, okay.
Yeah,
all right, whatever. I'm not gonna explain this stuff. Okay.
So we have some expanded knowledge about the function and the some related information.
Yeah, okay. Yeah, sure. Good point. Okay, I'll just end my explanation here. All right, so are there any questions to question number 2? If not, let's move on to question number 1 because Jaejon is here. All right, Jaejon, can you present question number 1? Oh, okay. Okay. All right, then let's go on to question number 4. So Davis, could you please explain question number 4? Davis, are you present?
Yes, I'm here.
Oh.
Don't worry.
All right. Oh wait, yeah, oops.
So question 3, yes?
No, question 4. Yeah.
My bad. For question 4,
Yeah.
so what I did here was I found out the answers, right? But so I then I'm not actually sure I couldn't find a simple solution to it.
Okay. Well, just explain your solution, and you can also use the share screen feature at the bottom of your screen, and you can click share and click whiteboard.
Oh, okay. Give me a second. Okay. So what I did, I didn't actually find a simple solution here. So I just replaced C, obviously. I'm pretty sure it doesn't really matter what C does. No, wait. Okay. I basically didn't find any simple solution to solve this. So I basically just guessed. And the numbers are all adding up to the same. And that was 45.
Okay, can you explain to me how you guessed? Oh wait, no. Oh, you mean that. Okay, yeah. Oops, my bad. Okay, continue.
Well, I guessed by, well, I just took a look and, well, I really don't have a simple solution to this.
Okay, well, can you tell me what a plus b plus c is? What do you get for a plus b plus c?
I got 47, is that correct?
Yeah, that's correct.
Okay.
Okay. Okay, can you explain how you guessed though?
I just put numbers that were close to the surrounding ones.
Mm-hmm. Okay. Sure, I guess that's a strategy you can use. Well, what other strategies do you think you can use for this problem?
I'm not sure, probably division.
Division? How would you use division in this problem?
You add them in a certain way and then divide them, but I really have no clue.
Oh, okay. Well, what about algebra? Do you think you can use algebra to solve this problem?
I don't know. Could you explain?
Okay, well, you can keep presenting. So we can solve this together. So what if you set the sum of a column, row, or diagonal as S?
All right.
And so we can look at every single row and every single column, right? We have A plus 13 plus B is S. 19 plus C plus 11 is S. 12 plus D plus 16 is S. A plus 19 plus 12 is S. And etc. So now the problem, yeah, so we basically have 9 equations, and actually not really 9 equations, but like we have 9 ways of expressing S as the sum of some of the numbers. So we could probably figure out what all of the variables are. But now the problem is that we have to like pick out the important equations. Like we can sit here with like how much is that? Like 36 equations scratching our heads, or we can pick out a few like a few equations that you think are important and try and solve those. So I have a question for you. Do you think any like column or row with D in it is useful?
Probably this one.
Which one is that one? Is it the A, C, and 16?
Yeah.
Yeah, okay, sure. You could say that A plus C plus, yeah, so you could say that that one's kind of important, but are any ones that include a D useful? Like for example, 12 plus D plus 16.
Oh, then probably this one.
Well, why would you need D though? Like what do you even need to figure out D?
No, you don't actually need to.
Yeah, so I don't think that the equations with a D are that useful because we don't actually need to know D and able to answer the question. Okay, so now looking at the other equations, So you can pick whichever one you want, honestly. So first off, you wanted to pick the diagonal, so a plus c plus 16. And then pick another equation. I mean, another row or column. Okay, well, we can write that down. For example, we write a plus b plus 13 is equal to a plus c plus 16. Oh yeah, also there's a function on the whiteboard which allows you to write text.
Yeah, I should do that.
Oh, it's a b, by the way. I think it's a plus c plus, yeah. Okay, so that's one equation. And what can we deduce from this equation? Can you simplify this equation to get rid of any variables?
We could maybe get rid of a, maybe?
Yeah, sure. And you can also condense all the numbers into one number. No, I mean like the numeric values, like 16 and 13.
Okay.
No, before you had 13 plus b is equal to c plus 16, right?
Mm-hmm.
Oh wait, just get rid of the plus sign and put an equal sign there. Yeah, okay. And then yeah. And then so we can subtract 13 on both sides. Right. Yeah, exactly. So we just simplified that equation. Okay, now which other so now we have information about B and C. Which other columns and rows or diagonals can we use that relates B and C?
Oh,
Yes, that's one of them. And then just pick another B or C row or column. Okay, and then make them equivalent because they're all equal to S. Okay, and if you simplify that equation, what do you get? Okay, yeah, B is equal to 18. Okay, so if we have B is equal to 18, then we see that, okay, so you can write down B is equal to 18.
all right.
Yeah, because we figured out B was equal to 18. And then we have B is equal to C plus 3, which means that C is equal to B minus 3. So C is equal to 15. Okay, so we know that C is 15 and B is 18. So we can figure out what S is equal to, and this way it'll be pretty straightforward to figure out what A is.
All right.
Okay, so as you said earlier, S is equal to 45. You can see that in the middle row, which means that if you take a row or a column with A inside of it, you can figure out A.
Hmm. How about we try this? So all right, since there's 45 and we know 45 is the answer from here, from the first equation, we can see that, well, 15 plus 16 is 31, and well, 45 minus 31 would be 14. It would be 14, so that means A equals 14.
Yeah, exactly.
All
So
right.
now we figured out the values of A, B, and C, and if
Now
you
we
add them
just add-
together, yeah,
Yeah,
it's equal to 47, like you said earlier.
all right. So that
Okay. All right, and
means-
so can you like summarize this problem and summarize like the key points and what you're supposed to do for this problem?
have to find the columns where there is A, B, and C, remove D, and we just cancel everything out, and then we can find out the values of A, B, and C.
Yeah, exactly. All right, so yeah, Davis pretty much said everything that could be said about that problem. So thank you for presenting. And oh yeah, Jason and Jaejon, could you please tell me when you are like back in your house and you can present?
Yeah,
Oh wait,
2 minutes.
all right. Oh wait, next person then is. Oh wait, oh I'm on the wrong thing. Oh wait, next person is going to be question number 5, Sean, if you would please present.
Okay, so the question is Jeanette picked a number, added 7 to the number, multiplied by 2, and then subtracted by 4. If the final result was 28, what number did Jeanette pick? So basically, for possible knowledge, I would say like you need to know distributive property and like just knowing how to solve an equation. And then I think the strategy I used was just setting up an equation. So first, I did, you know that they added 7 to the number. So you can call this number X, right? And then if you add 7, it's X plus 7, right? And then it also says that you multiply the sum by 2, which is just 2 times X plus 7 with brackets. And then minus 4, which is 28. And then if you know how to solve an equation, like you isolate the variable and then you add 4 on both sides. So 2 times X plus 7 equals 32. And then you can divide by 2. And then X plus 7 equals 16. And then X is equal to 9. And then, yeah, so basically you can find a number and it's 9. And the summary is just like solve the equation, and yeah, that's basically it.
Yeah, I think that's also, yeah, that's it. That's just it for the problem. And I guess it's the same thing if you work backwards as if you list out an equation. So not much to say there. Thank you, Sean, for presenting. And let's go on to question number 6. Ronald, if you would please present.
Also, Jaden and I can present now.
Oh, okay. You two can present next then.
All right. Okay, so for my question, it was the ratio of apples to bananas in a box is 3:2. The total numbers of apples and bananas in the box cannot be equal to what? So the words that I highlighted were 3:2. The total number of apples, but the total number of apples and bananas, and what the numbers of them cannot be equal to. And so basically what I did, I just looked at the ratios, which is 3:2, and I just added them together to get 5. And then, and that's because you want to look at the total number of apples, which will always be a multiple of 5. And because of this, I just looked at the answers, the choices, and I just chose the one that was not multiple of 5. And I knew this because a multiple of 5 is ends, or the ones digit of a multiple of 5 is either a 5 or 0. And the only number of the choices that was not a multiple of 5, or a number that had the ones digit as a 5 or 0, was it was E.
Yeah. Okay, and basically, like, I guess the basic knowledge is that you need to know how to work with ratios. But other than that, pretty straightforward. Thank you for presenting, and let's go on to Jason and Jajon, whichever one of you want to present first.
Jaden wants to present first.
Okay.
All right, so which one was question 1 again? I forgot.
Okay.
Can you screen share the question 1?
Okay. 1 second. Bruh. Wait one.爸，他这个在 whiteboard 里面开不了。
谁呀？
就是我这个题。
啊，Ctrl C 不行。
你看我 Ctrl C，等一下我 select 一下，可能这就是看还是不行。你不是说可以吗？Okay, whatever. I'll share the problems from here. Share screen. Okay. Wait, how do I?
你这个不行，你得
Okay, I can see the question now.
There we go.
Okay, so basically we take A and we plug in where it is in the equation, and we take B and we also plug where that is in the equation. So we get -3 multiplied by 2 minus 3 in brackets. And then, so first we can do the bracket equation. So 2 minus 3, you get -1. And -3 times -1, you would get a positive. And it would be a positive 3 because 3 times 1 is 3. So you get C.
Yeah. And the basic knowledge of this problem is being able to do basic arithmetic and multiplication. All right. Okay, so since this problem is kind of easy, and also since this problem, like, it has brackets and it has a something multiplying it outside, let's just talk about distributive property with this problem. As it has also come up in the previous problems. So Yeah, okay, so J-John, can you explain to me why A times in brackets B plus C is equal to AB plus AC?
So
So,
distributive
let me, yeah, distributive property.
So distributive property basically means that like when there's you multiply an operation inside brackets, then you have to multiply each of the individual numbers by the A in here.
Yeah, by the things in there. Okay. All right. Okay, well, I have a question then. Why can't I have A plus? Because we see that this is a multiplication symbol right here, right? A times in brackets B plus C is equal to AB plus AC. Why isn't A plus B times C equal to A plus B times A plus C? That looks pretty distributive to me.
Well, because AB, so here it's B times C. Then this is so it will get A plus BC, and if we did the simplification, then we get A plus BC, and that isn't AB plus AC.
Okay. Well, what about one more example, right? What if we do A divided by B plus C? Oh, okay, why is, okay, so first off, is A divided by B plus C equal to A divided by B plus A divided by C?
Because you have to go in, see, when you remove the brackets, you have to divide each term individually, or else you won't get the correct result.
Wait, so are you okay? I have a question. So the first question is this correct or not? For example, oh no, okay, yeah, sure, all right. Okay, so it's not correct. So Jason or Jijan, can you tell me why when I multiply it's correct, but when I divide it's not correct?
Because multiplication and division are different operations, and when you multiply, you have to go in individually, but when you divide, you don't.
Sure, fair enough. Okay, well, I guess another way to visualize this is if we like draw a picture, I guess. Wait, actually, I should be using my iPad to share screen. Oh, wait, I can annotate on here. Okay, let me see. All right. Okay, so let's try this, right? For example, if we take the first one, A times B plus C, and we want to see why it's AB plus AC, we can draw kind of a rectangle, right? So, oh, oops. Oh, 它需要按住。诶，还是用手指好一点。Okay, so if we have a rectangle, right? And we have the bottom as B plus C. B plus C. And then we have the side length as A. So we see that this entire rectangle is A times B plus C. And then we also see that this length is B. So if we do A times B, it's this area. And then if we add A times C, it's going to be equal to this area. So then A times B plus C is equal to AB plus AC. Okay, so that's that case. And what if we look at A plus B times C? If we do A plus B times C, I guess it's kind of hard to explain. So let's say that A is a line, right? A is a line of A. Or we can say that A is a rectangle of A by 1. And then we have, oh wait, let me just exit. There we go. And then we have B times C. B times C is also a rectangle. And then, so this is not equal to A plus B times A plus C, obviously, because like if we add the A side and the B side, so A plus B, and then if we add the A side and the C side, these two are obviously not the same. So therefore, they're not equal. And as for A divided by B plus C, I haven't come up with a good analogy for this one. So I guess I'll just let it be. And also some other people would, some people would say that like this A time, like the distributive property on integers is one of our axioms. So like they're one of the basic properties of our universe that we cannot prove. And it is a fundamental building block that we have to prove, that we have to use to prove other things. Okay, anyways, I'll stop rambling on about distributive property and continue to the next question. All right, Jason, would you like me to share my screen of the third question?
I would love that.
All right, let me just stop sharing for a second, and then let me find the third question. Oh, tetra. Okay, and back to Zoom chat. Share screen. Okay, let me just.
用那个 Paint 打开，然后这样的话就可以。
这上面没有 Windows 11，居然没有 Paint。
这样的。
就说，你说坑吧。
嗯。
Okay, whatever. Anyways, me just ranting on about Windows 11. Okay, oh yeah, Franklin, your turn is after this, because if you well, it depends on you. If you want to hear me ramble about question number 7 before presenting, then you can do that, but you can also present after. Okay, so Jason, go ahead.
All right, so first we know that the ratio of the number of skateboards to bicycles is 7-4, right? And we know that there were 12 more skateboards than bicycles. So first we know that in the ratio is always to like a certain scale, right? And the difference between the two ratios is 3. And then if we just divide 12 by 3, we get 4. So every one in the ratio should be 4 in real life. And then we just do 7 plus 4, which should be 11. And 11 plus 11 times 4 is 44. So it should be A.
Yeah, exactly. Okay. I feel like I can't really say too much about this question as well. You just have to know something about ratios. Okay.
I know.
And yeah. Okay, and then Franklin, would you like to present now or would you like to present later?
Later.
Later? All right. Okay, so I'll present question number 7 then. Let me just share my screen. Okay, so for question number 7, let me just read the question again, because some of you might not have looked over it. Number 7, for how many positive integers x does there exist a rectangular prism PQRSTUVW labeled as shown, with PR is equal to 1867 and PV is equal to 2019 and PT is equal to x? Okay, so first off, before starting this question, obviously, just read it one more time and circle the key information inside of that passage to make sure that you don't make mistakes. Anyways, all right, number 2, list the possible math knowledge and show them. So the possible math knowledge for a question like this, right? We look at this, so first off, we look at the figure, right? The figure implies that it's a geometry question. Geometry. Actually, I should say problem. So if it's a geometry problem, then we have to use our geometric tools. And what are we trying to figure out here? We're trying to figure out amount of positive x. And we know that x is a side length. So if we're trying to figure out side length in a geometry problem, then we're probably looking for the Pythagorean theorem somewhere. And this is especially true with rectangles. Especially true with rectangles. And it's especially true with rectangles because rectangles have 90-degree angles with them. So then you would easily draw triangles, which are right triangles. Okay, so that's the first part, right? So what else can we, like, we can't really see much else from the fact that it's a geometry problem and looking at the figure. Okay, so then if we look inside the problem, what is it asking, right? We're trying to figure out the amount of positive integer x. Oops, my bad, I forgot to write that. So if we're looking for the amount of positive integer x, then what we want to do usually is, like, we want to set bounds, because we know that there's infinite positive integers. So we have to set a bound to how high x can be and how low x can be. Oh wait, so the first thing is set bounds. And then we also, if we're looking for a positive integer, we can also look at the modulus. However, the modulus doesn't look particularly useful in this problem. And it's also usually not in a grade 10 contest. Okay, so we know that we want to set bounds on x. So with this knowledge, what can we do? Well, we can first set some variables and try and figure out how can we express x. How can we express x? And we can find the bounds of the things that are expressing x. So then we can use these bounds to figure out x's bounds. And if we know x's bounds, we can count the amount of x there are. Okay, so first off, let's set PQ. Let me write set PQ is equal to A, QR is equal to B, and QV is equal to C. Okay, so now we have set our variables. Let's see what some of our variables values will be. We know that PR is 1867. So by the Pythagorean theorem, actually, should I draw this out first? It's probably a good idea. There we go. Okay, so if we draw out the figure, bro, this iPad pen is so bad. Oh.还是不行。
把它变粗一点呢？是不是？
OK， 我操，好像不能变粗。
我试试。
你看不行吧？
这是什么情况？回头我再试试吧。我最外试给你。
Oh, okay. Well, it looks like we got scammed. Anyways. Okay, there we go. Okay, we cleared. Okay, anyways, I'm just going to use my finger to draw. Okay, so we have the rectangular prism. Okay, and let me just label the points. P, Q, R, S, T, U, V, W. Okay, so these are the points. And now if we look at all the points, right? So what is PR? PR is just, PR squared is equal to PQ squared plus QR squared, which means that A squared plus B squared is, actually, I'm just gonna, okay, so from now on, I'm writing the notation like this so that it's not like too messy, I guess, is equal to 1867 squared. And then we also have, what is it? PV. Okay, so PV is going to be equal to PQ squared plus QV squared. So A squared plus c squared is equal to 2019 squared. And then our last diagonal, PT, is equal to, so we see that PT is right here, right? And it's equal to PS squared plus ST squared. Oh, we don't have either of these variables. But we do have, we can find the value of QW, which is literally the exact same thing as PT. So we have QV squared plus QR squared is equal to RV squared, which is equal to PT squared. So we have B squared plus C squared is equal to X squared. Okay, so now we've listed these equations out. What can we do with them? So can we set any bounds on any of the variables here? We know that A has to be larger than 0, obviously, because it's in a rectangular prism, and you can't have a rectangular prism with a side length that is 0 or negative. And the same applies for B and C. Okay, so you have these values now, and what can we do with them? Well, if we notice that if we add these two equations up, and then we subtract by this equation, then we get 2a squared. 2a squared is going to be equal to 1867 squared plus 2019 squared minus x squared. Okay, so we know that this is going to be larger than 0 because a is larger than 0, which means that a squared is larger than 0. Okay, so we see that since 2a squared is larger than 0, this thing also must be larger than 0. And then we get our first bound. So our first bound is that we have x squared is smaller than 1867 squared plus 2019 squared, which requires a calculator. So this is why you should always bring a calculator to the CEMC contests. Okay, anyways. All right, so what is this equal to? Well, 1867 squared plus 2019 squared is going to be equal to a decimal. So then what is the number that is the floor of this number? Which means that basically like we want to get rid of the decimal since we're looking at x squared anyways, and x squared is a positive integer. Well, we get in the end that this is going to be 2,749 squared. Okay, so if we have 2,750 squared, then this value would be larger than these two values added together. Okay, now we see that the upper bound for x is 2,749. Now, what about the lower bounds? So to get the lower bounds of x squared, we can use the same equation again, right? 2a squared is equal to 1867 squared plus 2019 squared minus x squared. It's pretty clean because it doesn't have any b's or c's. Now, can we find an upper bound to a? Yes, we can, because we see that a squared plus b squared, we have an a squared in this equation, and we know that the lower bound for b is 0. So if the lower bound for b is 0, let's say b was equal to 0, then a would be equal to 1867. Therefore, a is less than 1867. And the same applies for a squared and c squared. A would be less than 2019, but 1867 already covers that. Okay, so if we continue on, we see that 2a squared, right, this value is going to be less than, we know that a squared is less than 1867. So we just do 2 times 1867 to the power of 2. I mean squared, whatever, it doesn't matter. Okay, and now we see that we have another comparison to get x squared, to get a bound of x squared. Okay, if we move the x squared over and we move the 2 times 1867 squared onto this side, then we will get x squared is going to be more than, I'm not going to compute this, x squared is going to be more, or yeah, just more than 768 squared. Okay, and this simplifies to, again, x is going to be larger than 768, which means that we have a range of values for x. So x can be anywhere between not including 768 to 2,749 included. Notice how I have different brackets. The left bracket means that 768 is not included. But the right bracket here, the square brackets, mean that 2,749 is included. So we just have to count the number of numbers. Okay, does anybody know how to count the amount of numbers in a list?
You subtract the big one from the smaller one and add one.
Yeah, exactly. But in this case, since 768 is not included, we don't need to add one back because we're basically doing 2749 minus 769 plus 1. And so if we do 2749 minus 768, this is going to be equal to 1981. So therefore, the amount of different positive integer x's is 1981. Okay, and as for the summary of the key points and tricks, the key points here is, as I said earlier, right, we have to figure out that if it's a geometry problem looking for side length, we need to use Pythagorean's theorem. And in this case, the applications for the Pythagorean theorem were pretty straightforward. And then we had to figure out ways to set bounds to the different numbers. So like x in specific, since we're looking for the amount of positive integers x. If we don't set any bounds, then we can have infinite x's because there are infinite positive integers. So then therefore, we have to set bounds for x. Okay, so if we set bounds for x, we found our bounds with some of the basic properties of a rectangle, like obviously you can't have a negative side length. And then from manipulating our equations, we were able to get in the end, with some help from the calculator, the bounds of x squared. And then after we found the bounds of x squared, it was just easy. We found the bounds of x, and then we counted all of the numbers in between. So yeah, that's pretty much, I feel like, the key points: setting bounds and Pythagorean theorem. Okay, now, yeah. So does anybody have any questions or comments to this problem? Okay, no? All right. Then let's move on to the next question. Question number 8. Franklin, would you like me to share a screen of the question?
No, thank you.
All right.
How do I do the whiteboard thing?
Whiteboard, just go to the bottom. Yeah. All right.
Okay, got it. Okay. So the question was that there's 3 consecutive odd numbers that's average is 7. Right? So if there's 3 consecutive odd numbers, that means that actually I won't go there yet. So there's 3 consecutive odd numbers that equal 7. And m is a 4th number that you add into these 3 numbers to change the average into a different integer. So just analysis of this question, we can figure out that we need basic arithmetic. We need to have an understanding of how averaging and stuff like that works. And we also have to understand even and odd numbers. So we also have to understand what consecutive means and what odd means, but okay. And so if the average is 7, that means that, and there's 3 consecutive odd numbers, means that 5 has to be one of the numbers, 7 has to be one of the numbers, and 9 has to be one of the numbers. Because, yeah, that's when you average them out, all equal 7, and they're consecutive, which is the only one, which is 5, 7, and 9. Now we're trying to find the 3 smallest possible values of m and add them all together. So what's important to recognize in this situation is that when we add a 4th, instead of dividing by 3, we're going to be dividing by 4. Now, 4 is an even number. And something very special about even numbers is that no matter what, if you want to get an integer from dividing by an even number, the number you're dividing by has to be even. So what do we know from that? We know that 5 plus 7 plus 9 has to be divisible by 2 and give a rational number. Well, not rational, like integer, that is. So that, and since we know the addition rules that odd plus odd equals even, we know that we know that all possible values of m will be odd. And from here, there's two ways we can go about it. So the way I did was I just went and tried numbers, because in the A, B, C, D, E, the highest number there was like 31, I think. So we know that no odd number over 31 is going to be there. So you can just list out all of the odd numbers up to 31 from 3 to, what was it, like 20 something, but 23, let's just say. And then you just try them all, which is quite inefficient because there's an even easier way to do it. So when you divide by 4, it means that 5 plus 7 plus 9 plus m has to be equal to 4, right? So when we add 5 plus 7 plus 9, it's equal to 21. And we know that 21 is 3 less than a number that is divisible by 4. So we know that no matter what, all the numbers that we can add together have to be at 1 less than a number that's divisible by 4. So then we just list out all of the integers again, which is 3, and it can't be 5, 7, or 9, 11, 13, 15. And while 11 is 1 less than 12, which is divisible by 4, 3 is 1 less than 4, which is divisible by 4, and 15 is 1 less than 16, which is divisible by 4, and those are the 3 smallest possible values. When you add them together, you get 3 plus 11 plus 15, and you get 29, which is B.
Yeah, exactly. So does anybody have any questions or comments on this problem?
Nope.
No? Okay. Well, as Franklin said, yeah, I guess the summary is that overall, you just have to understand averages, and you also have to know I can't say modulus, but you have to know divisibility, I guess. All right, so thank you for presenting, and that's going to be all of the questions for today. And before you all leave, I wanted to first off, let me ask, did you guys find the questions easy or hard for this week?
I found that question 7 was kind of difficult, but everything else was pretty manageable.
All right. Okay, easy, they're fine. Anybody else?